absolute value and adding real numbers. A new concept today is the idea of what is absolute value. The absolute value of a number is the distance from the number to 0 on a number line. The absolute value of 4 is written as, with these brackets, the absolute value of 4. So it's a measure in distance. Now what's unique about absolute value is that if it's measured in distance, it's always going to be positive. Even if it's a measure on the number line from, say, a negative number to 0, the distance overall is still a positive value. Our definition here is repeated. The absolute value of a number, n, any number, is the distance from n to 0 on the number line. That means the absolute value of positive numbers and negative numbers are going to be given a positive value. If you look at the example problems right here below, the absolute value of 0 is 0. The absolute value of 7.12 as a decimal is 7.12. You can actually do mathematical expressions within absolute value and then apply the absolute value to what you find inside of that actual expression. We're going to treat these absolute value bars on the outside, these parallel lines, as kind of parentheses. So in letter C, it's 1 minus 3/4. Now 1 would be the same as writing 4/4, so 4/4 minus 3/4 equals 1/4. The absolute value of 1/4 is going to be 1/4. If you would draw 1/4 on a number line, that's where you would find that distance to be measured in that way. Letter D, negative 11 minus 2. Now this negative outside of this absolute value symbol, which is going to be important. Here you're going to simplify within the absolute value bars. So 11 minus 2 is 9. Outside of the value is the absolute value, so 9 is positive, but because the negative is outside, it doesn't get canceled by these absolute value bars, and it can remain as a negative answer. So you have to pay really close attention to where that negative value is. If it's in front of this number here, it's inside of the absolute value bars, then it would be canceled out, because even if it's a negative number, the absolute value is that distance, again, is positive. If you look at our exploration, it's going to model for you what this means in terms of adding real numbers. There's a way in which we want to understand absolute value, because if we understand absolute value, it allows us to quickly assess the addition and subtraction of real numbers. Now the exploration here has you find the sum using these algebra tiles or these blocks. You can see that anytime you've got a positive and a negative value that are next to each other, technically those are going to cancel each other to then give you what would be the answer. So negative 5 plus 3 is negative 2. Here's where these would cancel out. What you're left with is that negative value. Now on a number line, you would start at 0. It would say negative 5. You'd go backwards 5 in this left direction, and then plus 3 is forward right. Well, where do you end up? Right at negative 2. Both of these methods are really, really effective for using addition and subtraction with positive and negative numbers. However, it might not be the most efficient way if you to draw these tiles out every time or to use a number line and trace your finger back and forth. So we're actually going to learn a way in which we can do this as quickly as we can with a couple rules for adding real numbers. Now this says use algebra tiles to find the sum. You don't necessarily need to practice with that, but it is beneficial if you're going to. You draw 4 positives, 3 negatives, they'd cancel, you'd be left with 1 positive. 2 negatives and 6 other negatives is a total of 8 negatives, so negative 8. Here you've got 7 negatives and 7 positives. Those would all cancel out, and your answer would be 0. Now, here in this generalized section, it asks you to determine whether each statement is true or false. Provide a counterexample. Remember, our counterexample is a way in which you are going to say what is the actual way that it would be represented. So let's take a look. D, the sum of 2 positive numbers is always positive. It's true. 2 plus 2 is 4. 4 plus 4 is 8. 5 plus 2 is 7. Anytime I'm adding positive numbers, it becomes another positive number. Letter E, the sum of 2 negative numbers is always negative. This is also true. Negative 2 plus negative 2 is negative 4. If I'm adding negative values, it becomes actually more negative. Now, letter F, the sum of a positive and a negative number is always negative. We're going to say that that's false. If I've got positive 4 and negative 2, I'm left with positive 2. That's not a negative number, therefore this is false. So we're going to try and find out the way in which we actually figure out a pattern between positive and negative numbers when we're adding them up. If they're always positive, they're positive. If they're always negative, they're negative. That's easy to remember. But what if we mix those two values together? Here's where we have our rules for adding real numbers. In this top section, it says adding numbers with the same sign. Mr. Shane is going to teach you a quick little saying that applies to both positives and negatives that is really helpful for remembering and establishing a quick way in which you can add these up. It's same sign sum. If you see that two of these numbers here, this 3 is positive, even though it doesn't have a symbol in front of it, anything it doesn't have in front of it would be considered positive. 3 is positive and 2 is positive, so same sign sum. 3 plus 2 is 5. In this example, you've got a -3 and a -2. Same sign. The sign we're talking about is positive or negative. Same sign, sum. Add them up. 3 plus 2 is 5. Or -3 plus -2 is -5. Keep the same sign. The sum will have the same sign as the addends. So my statement again is same sign sum, keep the same sign. Same sign sum, keep the same sign. Sing along with me. Same sign sum, keep the same sign. All right, hopefully that's ingrained in your brain, and hopefully it's like one of those songs that just gets stuck in your head. Same sign sum, keep the same sign. Next, you've got adding with different signs. What if you've got a positive value and a negative value, or a negative value and a positive value? Here's where that pattern didn't remain the same. We found that we had to have a counterexample from what was our generalization in the previous example. To add numbers with different signs, find the difference of their absolute values. The sum will have the sign of the addend with the greater absolute value. What that means, if you've got two different signs, it says find the difference. Another term for difference is actually subtract those values. Now, it asks us to put them in terms of absolute value for both of these terms. That's why we were practicing with how to actually calculate absolute value. You put things into absolute value for adding real numbers, it makes it a lot easier. So even if I have a positive number and a negative number, I'm going to put them both into absolute value terms. Let's try it here. We got different signs, so we are going to find the difference. My little phrase for this one is different, different, subtract. Different, difference, subtract, because the term difference actually means to subtract those two values. So I would have positive 3 plus negative 2. Now I'm going to change those into absolute values. It would be the absolute value of 3 and the absolute value of 2, but instead of adding those, I'm finding the difference. I'm subtracting. So what's 3 minus 2? 3 minus 2 is 1. Look how that works out. Here you've got negative 3 and positive 2. It equals -1. Let's check with our different, subtract. Positive value would be positive 3. Absolute value would be 2. And now you're subtracting those, finding the difference between 3 and 2. 3 minus 2 is 1. You're going to keep the sign of this larger number. Here's where it says the sum will have the sign of the addend. Keep the sign of the larger number. Absolute value of 3 is larger than the absolute value of 2. Therefore, the sign with this larger number was negative. It's going to get planted right here. Again, same sign sum, keep the same sign. Different, subtract. The sign comes from what was originally the larger number. So in this one, the larger number was 3, it's positive. The larger number was -3, absolute value-wise, and it's negative. In example 2, it asks you to practice adding those real numbers, and here we are going to see Mr. Shane's rapid-fire, quick little sayings become really useful. Different, subtract. 21 minus 12, the absolute value of those, 21 minus 12 is 9. Now, which one of these was larger in absolute value? The absolute value of 21 or the absolute value of 12? Absolute value of 21, therefore my answer is going to be positive. Letter B, -19 plus -8. Same sign, sum, add them up. 19 plus 8 is 27. Keep the same sign, keep the same sign, keep the same sign. Negative is our sign, keep it negative. Letter C, this works for decimals, and in letter D, it works for fractions. 3.2 plus -5.1. When you're adding those decimals, you need to line those decimals up so that you're adding them correctly. But here you've got difference, subtract. You'd subtract the absolute values of those. So you'd have the absolute value of 5.1 minus the absolute value of 3.2, and your subtraction in this case would figure out to be -1.9. Now why is it negative? Because the absolute value of 5.1 with the original negative sign was larger, so it keeps that negative sign. Letter D, -3 plus -1/5. You got same sign sum, you can add them up. When you're adding fractions, they need to have common denominators. In this case, they do. So -3 is added to -1, you're going to get 3 plus 1 is -4. In example 3, it asks you to identify sets of real numbers closed under addition. Again, something is a closed set if the numbers themselves in the beginning of the expression are the same as what would be in the solution to the expression. So this asks us to determine whether each statement is true or false. Give a counterexample. A, the set of integers is closed under addition. Can I add two integers and get another integer? That statement is true. Two positives would make a positive, two negatives make a negative. When I add positive and negatives, guess what? It gives me either a positive or negative. We just learned that, but it's also considered an integer. Letter B, the set of real numbers is closed under addition. That would also be true. Any real number added to another real number is going to give me a real number. In example 4, it asks us to apply this in terms of what you are adding and subtracting with real numbers, positive values and negative values. And it just so happens to show up in what would be a football scenario. On the first down, the Cougars lost 4 yards. That means they went backwards. They gained 7 yards on the second down. They got it going in the right direction. Use addition to find the total number of yards lost or gained on the first 2 downs. You can see here in our solution how it's set up. If you lost yards, that's negative. If you gained yards, that's positive. Find the difference between those because it's different signs. Different. Subtract. 7 minus 4 is 3. Because 7 is the larger absolute value, the answer here is going to be positive because 7 was positive. So they went positive 3 yards after those 2 downs. It's time for our lesson 5 practice problems because remember, practice makes permanent. Practice doesn't make perfect, only Jesus was perfect. Practice makes permanent. We want to take these skills, put them in our brain and keep them there as we build on what we're going to learn for the rest of the year. Let's take a look at practice problems A through F. In the first portion of our lesson today, you learn about absolute value, which is going to demonstrate that any number within these brackets is going to be given a positive value, kind of like you're measuring distance. Distance is always measured positively. So a absolute value symbol is going to cancel out that negative and give us the absolute value of negative 3.4 is actually 3.4. Letter B, it can be applied to fractions or decimals. The absolute value of 6/7 is going to give me 6/7. Gives that positive value regardless if it's a fraction or a decimal. Letter C, you've got a mathematical equation inside of our absolute value. This is considered a symbol of inclusion, so like parentheses on the outside, you're going to do what's inside those parentheses first. We're going to take a look at the addition here, 14 plus negative 22. I know that when I'm adding real numbers and I've got different signs, I actually find the absolute value of each of those and then the difference between those. So what is positive 14 and negative 22? The difference between those would be subtraction and then keeping the sign of the larger number. So 14 minus 22, if I'm thinking about it in addition terms, but then changing it to a subtraction problem because it has a different sign. Different, subtract. You could also think about it as 22 minus 14 instead of 14 minus 22 to give me what would be that real value. 22 minus 14 is going to be 8. Because that value is negative, that is larger here, the answer is negative, but then again, you've got the absolute value symbols that are here that would then cancel out that negative to give me my real answer of positive 8. Okay? Letter D has, again, mathematical expression, 7 plus 16, inside of my absolute value brackets. Therefore, I got to do what's inside, and then outside would apply afterwards. 7 plus 16, that's going to be, let's see, 23. And our absolute value symbol would make this positive, but because the negative over here is outside, the answer is going to be negative. Letter E asks me to find the sum of this value. You've got negative 23.4 and positive 18.72. In order to set this up, I'm looking at adding real numbers, and I would say that they have a different sign because this is negative and this is positive. Therefore, I'm finding the difference. Same sign, sum. Different, subtract. So I would subtract these two values. I've got 23.4 minus 18.72. I throw a 0 in here. We would say that this is 0 minus 2 can't do, so you have to borrow. This turns into a 3. 10 minus 2 is 8. 3 minus 7 can't do, you got to borrow. 13 minus 7 is 6. You've got to borrow again. 1 is going to become 12. 12 minus 8 is 4, and then 1 minus 1, you get 4.68. Now is that positive or negative? Because the larger number was negative, you would have a negative remaining. Letter F, let's try the sum of what would be fractions in this case. You've got negative 2/3 plus negative 1/6. Now whenever I'm adding fractions, I need to make sure that I have a common denominator. So can I change one of these so that they're in the same terms as each other? I can. To do that, I'd have to multiply by both the numerator and denominator by the same thing, a factor to get it equal to 6. So I know that 3 will turn into that if I multiply this by 2 And if I do that, I got to multiply both. So now 3 times 2 is going to be 6, 2 times 2 is going to be 4, and I've got a problem that says negative 4 6 plus negative 1 6. Now when I have a common denominator, I'm not actually adding those denominators. I can just add across the numerator and give the same value here. Here I've got a negative and a negative. When I have the same sign, I sum them up. Same sign sum. Negative 4 plus negative 1 is negative 5 6. Our practice problems for letters G, H, and I ask us to determine whether each statement is true or false. Give a counterexample for the false statements. Now, this is coming from example 3, so if I scroll back up and we take a look at example 3 just for a quick review, it asks us to identify sets of real numbers closed under addition. Remember from previous lesson, something is closed, a set of numbers closed as if the same numbers that are in the beginning of the problem become the solution at the end of the problem. So if you look at letter A and B here, it says determine whether each statement is true or false. Give a counterexample for false statements. It's asking us to do the same thing in our practice problems. Letter A, the set of integers is closed under addition. You should think to yourself, if I add an integer to another integer, do I get another integer? Statement is true because the sum of any two integers will also be an integer. If I add two positive numbers, I'm going to get a positive number. That's an integer. If I add two negative numbers, it becomes more negative. Same sign sum. It is also going to be a negative number, so that is closed under addition. Letter B, the set of real numbers is closed under addition. If I add a real number to a real number, does it make a real number? Being that real numbers is the largest scope of all the numbers that we can consider in mathematics, this statement is also true because the sum of any two real numbers will be a real number. Add any real number to another real number, you're always going to get a real number. Let's take a look at those practice problems then to apply what we just reviewed. Letter G, the set of rational numbers is closed under addition. If I add a rational number to a rational number, it's going to give me a rational number. If I add fractions to fractions, it gives me another fraction. If I add decimals to decimals, it can give me another decimal. Rational numbers can include all of the numbers that are categorized in that side altogether. So that would be true. H, the set of positive integers is closed under addition. If I add a positive number to a positive number, it's going to give me a positive number. H would also be true. Letter I, the temperature at 7 p.m. was 34 degrees Fahrenheit. The temperature fell 12 degrees Fahrenheit by midnight. Use addition to find the temperature at midnight. Here you're going to apply what we learned in example 4, in which you're using a word problem to come up with what would be the positive and or negative values of that example. So the positive value of 34, the temperature fell, is going to give you indication that this is a negative number, so you're adding a negative 12 to 34. 34 plus negative 12 would be the expression that you would write out. You would understand that it has two different signs, so you're going to find the difference in the absolute value of those. So you have 34 minus 12 to give you a total of 22 degrees Fahrenheit.